Good morning to all. This is in continuation with the previous topics. So far, we concluded unit step function, unit impulse function under continuous and discrete time signals. Now, the third one, that is exponential function, now we are going to discuss. Let us start. Let us start. Now, the third one is exponential function. Now we are discussing exponential functions, exponential signal. Here, whether or whenever we use the word signal or function, both are same. No need to have any confusion. In mathematical notations, generally we use most frequently used word is function. So here in sometimes instead of signal, generally we use function, but both are same, signal. Exponential signal. Here e power alpha t is exponential signal. E power alpha t is exponential signal where alpha is a constant but not equal to 0, where alpha is not equal to 0. That is very much important, not equal to 0. If it equals 0, what happens? We will discuss. Now, we have to discuss exponential signal with respect to continuous time signal, and we are discussing exponential function with respect to discrete time signal as well. Now just look at, so far we discussed unit step, unit impulse functions under these two concepts. Same exponential signal will also be discussing under continuous time and discrete time signals. Now let us start with the first one, continuous time signal. In continuous time signal, what are the functions we are considering? E power alpha t. Here two cases arise. Look at e power alpha t, two cases arise. The first one is called alpha less than 0 and alpha greater than 0. If you want, you can make it, but not required, alpha equal to 0, but not needed. Actually, it is alpha not equal to 0. If equal to 0, what happens? That only I will discuss as a third case for your understanding purpose, but not needed. Now let us. The sub one is called when alpha is less than 0. Whenever alpha is less than 0 means what? The number is a negative number. The number is negative number. In this case, the signal will become e power minus alpha t. The signal will become e power minus alpha t. Now in this case, the sketch of this graph will be like this. T, this is e power minus alpha t. For all the values, same, minus 1, minus 2, minus 3, this is 0, 1, 2, 3, like this, continuous. For example, alpha equal to 0, what happens? E power 0 equal to 1. Therefore, amplitude is equal to 1. Whenever the signature or the alpha value is negative, now just look at, it passes like this, it goes like this, the graph goes like this. Now it passes through 1 point because e power 0 equal to 1. This is the graph of e power minus alpha t, e power minus alpha t. Suppose if you go for the same under discrete time signal, then what happens? Now just look at, same, here n, this is e power minus alpha n. Here just look at, for same, n equal to 0, its value equal to 1. For understanding purpose, just I am making only dotted line. Now just look at, this is minus 1, minus 2, minus 3, etc. Just look at. Look at, etc., etc. Look at this one. This is the discrete time signal representation of e power minus alpha t. Again, I am repeating, exponential function means e power alpha t, where alpha is not equal to 0. We have to discuss under continuous time and discrete time. Under continuous time, now when alpha is less than 0 means what? Negative value. Now it comes under CTS, continuous time signal representation. It comes under discrete time signal representation. Now just let us explain second case. Second case is alpha is greater than 0. In this case, it is alpha t. That means what? Alpha is positive. Now, here just look at. This is the continuous. Now I am sketching under continuous time signal. This is e power alpha t. When alpha becomes 0, its value equal to 1. Same values 1, 2, 3, 4, etc. This is minus 1, minus 2, minus 3, etc. Now here, graph like this. Look at, it comes like this, opposite way. Reverse is e power alpha t. In the both cases, it passes through 1, 1, because when alpha equal to 0, its value equal to 1. Okay. Now, under discrete time signal, how the sketch could be? Now just look at. Here we use n. This is u of n. Not u of n. This is e power minus plus alpha n. Now, in this is plus alpha t plus alpha n. Its value is equal to, just look at, it's equal to 1. Now, just look at, in this way, the graph raises. Now just look at, this is the way of continuous graph. This is the way of discrete graph. Just look at the difference. These two differences students have always look into this one. Okay, so exponential function e power alpha t under continuous, under discrete. In how many cases are we discussing? Alpha less than 0, alpha greater than 0. Now I will tell you. This case is not required for our understanding purpose, your understanding purpose. I am considering this case alpha equal to 0. Let us 0. As a special case, if alpha equal to 0, what happens? What is the signal? E power alpha t is the signal. X of t is e power alpha t is the signal. When alpha becomes 0, what will happen? X of t will become e power 0. E power 0 equal to 1. Now, under continuous time signal, what will happen? This is t. This is e power alpha t. When alpha equal to 0. When alpha equal to 0, what happens? Only 1. For all other values, minus 1, minus 2, minus 4. 1, 2, 3, 4. Look at, this is the graph of alpha equal to 0 under continuous time signal. Now, under discrete time signal, what will happen? Now let us consider the discrete graph. This is n, this is e power alpha n. When alpha equal to 0, when alpha equal to 0, its value equal to e power 0. E power 0 equal to 1. So amplitude is only 1. So here it represents only this 0. Remaining values all are zeros. All are zeros. Now just look at. So here under continuous time signal, x of t, that is equal to e power alpha t when alpha equal to 0. Under discrete, this x of n, this is equal to e power alpha n when alpha equal to 0. Look at this one, same compositions. This is continuous, here it is discrete. This is discrete. So this is the differences, these are the differences between the properties and sketches of this exponential function. So now just we discussed an exponential signal e power alpha t under how many cases? 3 cases. When alpha is less than 0, second one, alpha is greater than 0. As a special case for understanding purpose, alpha equal to 0. These 3 cases, we discussed this topic under continuous time signal, under discrete time signal. These are very much important for this one. Here, just look at, now, under signal models, now we discussed unit step function, and in the second case we discussed unit impulse function. Function means signal. Unit signal. Unit impulse signal as third one. As a third one, we discussed exponential signal. Exponential signal. Students have to remember and analyze the sketches and mathematical modeling of these 3 functions, 3 signals under the concepts of continuous time signal and discrete time signal as well. These 3 are very much important. So under exponential signal, the actual definition is like this: x of t equal to e power alpha t, where alpha is not equal to 0. Not equal to 0 actually. If it happens 0, what will happen? For your understanding purpose, as a special case, we discussed this under continuous time signal, under discrete time signal. Now just look at these 3 signal models. Just we discussed previously in the previous class, we discussed the first 2. In this session, we discussed exponential signal as well. So these 3 come under signal models. Now in the next session, just we are going to discuss what is the properties of signals and what is their impact on these signal models. What is their impact, especially on unit step function and unit impulse functions? What will be the impact of signal properties? That is time shifting, time scaling, or time inversion. In the beginning classes, we discussed that one. Just we are going to discuss the impact of signal properties on these signal models. We are going to discuss the next session immediately. Thank you.